Okay, this is an introduction to getting you started with the PICAXE Create board. So once you've got your PICAXE Create board out of the box, you're going to need to connect the battery clip, making sure you get positive and negative the right way around, red and black the right way around, making sure you're gripping with the terminal block onto the wire, not onto the plastic sheathing. And to do this, you'll need a flat blade screwdriver or a Phillips screwdriver, that's a crosshead screwdriver. You'll need a battery pack with 3 AA batteries, each of which is 1.5, giving you 4.5 volts. Now that's useful because the maximum voltage for a PIC microcontroller, programmable interface controller, is usually 5 volts, although you can sometimes get away with 6. So don't ever use a 9 volt PP3 battery, that's the rectangular one, or else you might damage, well, you almost certainly will damage the PIC chip. So I've connected in the LED module using the special connectors, so you'll need to read the manual on how to do that, and everything you need to do that is in the box. And we're going to get you started with the software. So I've already opened the App Player here to save a bit of time, and I've typed in PICAXE, which is the brand name of this particular group of microcontrollers. So we're going to search for that, and the option we want is the PICAXE Programming Editor. So I'd recommend you put that in favourites. I've already done that, so I'm going to click Run. And that will open up into the freely downloadable interface. Now, you'll automatically get faced with this options in most cases, but just in case you don't, or just in case you need to change options part way through a tutorial, I'm just going to click Cancel with that and just point it. You can find options in View and Options, or you can also just click this Options button. And what we need to do is, if you read on the board, you'll see it's labelled up there as PICAXE 18M2. So we need to make sure that the PICAXE 18M2 is selected. I suspect it'll be defaulting to the 20M2, so make sure you've got that changed. The next thing you're going to need to do is make sure it's set up for the serial port. So there's 2 things we need to change. So we'll need to plug in at this point our USB download cable into one of the USB ports of the computer, and the jack socket at the end will insert into the download socket on the board, just like so. So on this, it's identified here as AX027 PICAXE USB. That's what I want it to be connecting to, so it needs to be COM port 3. I'm going to apply that. Okay, so we can see at the bottom of the screen here, it's telling us PICAXE 18M2, that's telling us COM3. So next thing I need to do before I run a test program is make sure it's plugged in. That's a key thing which can go wrong in the classroom. So always one of the first things to ask is the download cable connected? Is there a battery pack connected or a power supply connected? So make sure those go the right way around. Connect like so. So the wires always go over this part here. So I'm going to pop this down, and I'm just going to click the program button, and we're going to see if this downloads a blank program. So that's a good starting point for us. So it hasn't done that, and that's because the third option I haven't switched on just here. So I'm going to click OK, click Program again. So those are 3 typical things which can happen even before you start to get programming. So you can see the progress bar will run twice, and that'll tell us it's downloaded a program. Now, although there's nothing in the program, there is some information being downloaded onto the computer, which is why it's saying 3 bytes out of 2048. So I'm going to click OK, and now I'm going to start by writing my first simple program. And what we want to do is we want to make the LED flash on and off. So we're going to use some simple language commands. We're going to make the output go high, then we're going to make it go low, and then we're going to make it repeat. So the first thing we're going to put in is something we call a label. So we usually call the main part of the program main, and that's our starting point. So that's called a label. It's a little bit like a front door in an address. So we know it's a label because we've got this colon after it, and that's what marks it out as a label. So we're going to start by typing in high, which is the command to make an output go high or switch it on, and then B.1, and B.1 is the name of the output on the board. So that's what we're switching on. So the tab in just signifies that this is part of this subroutine which has the label main. I'm going to put in here pause 500, so we're going to put a delay in. We want it to be on for 500 milliseconds, so 500 thousandths of a second or half a second. We could also use wait commands, which are in full seconds, but the pause gives us a bit more control. After it's been on for half a second, we want to switch it off, so we're going to make it low 3.1, and then we want it to repeat, so we're going to put a pause 500, so we're putting it on for half a second, off for half a second, and then we want to get it to repeat. And the command for that is go to main. And that program will run through, so switch B.1 on, wait half a second, switch it off, wait half a second, and then go to main. So that'll just loop around. So we learned a little bit about program flow control. And some other things which can go wrong in the classroom, or things you can use as pedagogy. You can try programming it and not putting in a pause and see what happens. So if we don't have this pause here, after it goes low, it'll go high, pause, low, then immediately back, and this is happening around about every step is around about a 4,000th of a second. So it does 4,000 steps in a second at least. So apart from the point at which it's pausing here, if we take this pause out, it's going to go virtually immediately to high, so we won't actually notice it going off. So let's try downloading this. So I'm going to hold this up so we can see what happens. So we can see the LED indicator is on there. I'm going to press program. So we get running here, we've got the progress bar. So again, that will run through twice. And then we should see a moment later, there we are. So it's told us it's been successful. So it's 14 bytes this time, so you can see that those 6 lines of code have translated into those 14 bytes. I'm going to click OK. So we've got flashing LED just here. And now what we can do for this, we can prove that this is independently programmed. We can disconnect that from the computer, so that's still running. We can also prove that it's flash memory, it's reprogrammable, and it's non-volatile memory. So we can switch this off. We can even disconnect it from the power supply and connect it back up again, and then switch it on. And there we go, so the program's been remembered. So it's non-volatile memory, means that when you take the power supply away, it'll keep its memory, keep what's stored in its memory. And that's it. That's your first program using the PICAXE microcontroller and using PICBasic language, so programming language. So Basic's it's been around for quite a long time, and this is a version of Basic, sometimes either called PBasic or PICBasic.